In the first question, it says, find the highest common factor, HCF, of 63 and 105. So let's draw the tree diagram for both 63 and 105. So we know 63 can be split into 7 times 9, and 105 can be split into 5 times 21. Now, if we talk about splitting 7 and 9, we know 7 is a prime number, so that cannot be split into anything. But 9 is not a prime number, and that can be split into 3 times 3. 3 is a prime number once again, so we cannot further break it down. So this is the prime factorization of 63. Going to 105, that is split into 21 and 5 right now. 5 is a prime number, so we cannot further break it down, but we can break down 21, which is 7 times 3. So as we said that 7 and 3 are prime numbers, so we cannot further break them down. So as you can see, the common factors are 7 and 3. 7 times 3, which is 21. That is your HCF of 63 and 105. Question 2 says, write 5.3 times 10 to the power 4 as an ordinary number. So in ordinary numbers, basically what happens is that we don't have the times 10 to the power of something. We write the entire number. So since it's 5.3 times 10 to the power of 4, which means we're going to move the decimal 1, 2, 3, 4 places to the right. So that's going to give us 53,000. Then it says write 7.4 times 10 to the power of -5 as an ordinary number. So now since the power is negative, so we're going to move the decimal 5 places to the left-hand side. So we have 7.4. So we have 7.4 over here. So 1, 2, 3, 4, 5. So that's going to be 0.000074. Then it says calculate the value of 9.7 times 10 to the power of 6 plus 2.45 times 10 to the power of 7, giving your answer in standard form. So what we can do is we can take 10 to the power of 6 common. So that's going to leave us with 9.7 times 2.45 times 10 inside the bracket. 9.7, this is plus 24.5, because 2.45 times 10 is 24.5. Add the 2, and that's going to give us 34.2. So now what we have is 34.2 times 10 to the power of 6. And since it says standard form, in standard form, your decimal comes after the first non-zero digit. So then it's going to be 3.42 times 10 to the power of 7. Since we're moving the decimal one place, so we're going to add 1 to the power as well. So it becomes 7. So 3.42 times 10 to the power of 7. That is your answer. Question 3 says the diagram shows a solid triangular prism. Rana is trying to draw the side elevation of the solid prism from the direction of the arrow. Here is your answer on a centimeter grid. Explain why Rana's side elevation is not correct. So the reason why her side elevation is not correct because the distance, this perpendicular distance, is not going to be 4, but it's going to be this distance. Side elevation is basically going to be this. This is what we're seeing. She's using the value of 4 for this distance, but we don't have that value because if we use Pythagoras to find that value, this is 3, this is 3. So if we say 4 square equals to 3 square plus h square. That's 16 minus 9 square root, and that's square root 7, which is not going to equal to 4. So this is why her drawing is incorrect, because the height is wrong. So you can just write it as height in the drawing does not match the calculated height. That's your answer. Then it says on the centimeter grid below, draw a plan of the solid prism. The view that we see from the top. So 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7. And then we have this line over here. So this distance is 4, this distance is 4, this is 4, this is 4, and this is 7. This is going to be your view of the plan of the solid prism from the top. Then it says a company has 25,000 workers. The number of workers increases at a rate of 6% per year for 3 years. Calculate the total number of workers at the end of the 3 years. So since it's an increase and it's an exponential increase, the formula we're going to use is the initial value, which is 25,000 multiplied by 1 plus the rate, which is 6 over 100. Always write it as a fraction or a decimal, not as a percentage, to the power of the time, which is 3 years. So 25,000 times 1.06 to the power of 3. And that is going to give us 29,775.4. That is total number of workers at the end of the 3 years. Since it says number of workers, so obviously it has to be a whole number. So it's going to be 29,775. That's your answer. Question 5 says Habib has 2 identical tins. He puts 600 grams of flour into one of the tins. The flour fills the tin completely. The density of the flour is 0.6 grams per centimeter cube. Then Habib puts 600 grams of salt in the other tin. The salt does not fill the tin completely. The volume of the space in the tin that is not filled with the salt is 700 centimeter cube. Work out the density of the salt. So first, we're going to begin with finding the volume of the tin. So volume of the tin is going to be your mass of the flour, which is 600, divided by the density of the flour, which is 0.6. Since the question says that this tin was completely filled up with the flour, so that means the volume of the flour is going to be the same as the volume of the tin. Hence, we're dividing the mass of the flour by the density of the flour to get the volume of the tin, which will be the volume of the flour as well. And that gives us 1,000 centimeter cube. Now, since the tins are identical, that means the volume of the other tin is also going to be 1,000 centimeter cube. Since the volume of the space in the tin that is not filled with salt is 700 centimeter cube, that means volume of the space filled with salt is going to be the difference of 1,000 and 700, which is 300 centimeter cube. So now we can easily use this to find the density of the salt. Which is going to be mass of the salt, 600, divided by the volume of the salt, 300. which gives us 2 grams per centimeter cube. That's your answer. Question 6 says Tim has two biased coins, coin A and coin B. He is going to throw both coins. The probability that the coin A will land on heads is 0.6, and the probability that coin B will land on heads is 0.55. Complete the probability tree diagram. So if the probability of landing on heads is 0.6, probability of not heads is going to be 1 minus 0.6, which is 0.4. Similarly, for B, if the probability of heads is 0.55, for not heads, it's going to be 1 minus 0.55, which is 0.45. This will be repeated over here because the probability is not changing for coin B for heads and not heads. So 0.55, 0.45. Tim throws coin A once and he throws coin B once. Work out the probability that both coins land on heads. So for both coins to land on heads, this is the rule that we're following. So it's going to be 0.6 multiplied by 0.55, and that is going to give us 0.33. That is the probability of the coin landing on heads both times. Question 7 says a paddling pool is in the shape of a cylinder. The pool has a radius of 100 centimeters and the depth of 30 centimeters. The pool is empty. It is then filled with water at a rate of 250 centimeter cube per second. Work out the number of minutes it takes to fill the pool completely. Giving your answer correct to the nearest minute, you must show all your working. So firstly, you need to remember volume of a cylinder has the formula of pi r square h. Radius is 100. Height is 30. So that is going to give us 942,477.796 centimeter cube. Now, since the rate at which the water is being filled is 250, so 250 equals to the volume divided by time. So this is our volume, and time is what we're trying to find. So time in seconds is going to be this divided by this, which is going to give us 3769.91 seconds. Now, time in minutes is going to be 3769.91 divided by 60, because 1 minute has 60 seconds. So 1 second has 1 over 60 minutes, which is going to give us 62.83 minutes. Since it wants the answer correct to the nearest minute, so nearest minute is going to be 63. That is your answer. Question 8 says, on the grid below, draw and label the vector 2a plus b. So let's first find the vector 2a plus b. 2 times 3 times 2 plus -1, 4. 2 times 3 is 6. 2 times 2 is 4. Plus -1 and 4. 6 minus 1 is 5. 4 plus 4 is 8. So this is the vector that we need to draw. So that means we're going to go, we start from over here. We're going 5 units to the right. So 1, 2, 3, 4, 5. And we're going 8 units up. So 1, 2, 3, 4, 5, 6, 7, 8. This is your vector 2a plus b. Question 9 says diagram shows a cube and a square-based pyramid. The volume of the cube is equal to the volume of the pyramid. Work out the perpendicular height, 8 centimeters of the pyramid. So volume of cube, volume of cube is basically length being cubed. So in this case, our length is 6, so 6 cube, which is 216 centimeter cube. Now, 200 centimeter cube is the same for the pyramid. So 216 equals to volume of the pyramid, which is 1 over 2 times the base times the area of the base, which is 8 square, times the height, which is h. Volume for this is 1 over 2 times base area times the height. So 216 times 2 equals to 64 times the height. Divide that by 64. And that is going to give us 6.75 centimeters as the height. Next question says there are only red counters and yellow counters in bag A. Number of red counters is to number of yellow counters is 3:5. There are only green counters and blue counters in bag B. The number of counters in bag B is half the number of counters in bag A. Given that there are X red counters in bag A, use algebra to show that the total number of counters in bag A and bag B is 4x. Okay, so let's start with the red is to yellow ratio. So that's 3:5, which means if we use the red one, red is basically 3/8 of total. Total count is for A, so I'm going to write total A. So red counters are given as X. So X is 3/8 of total A. So which means if we make total A the subject, so that's going to be 8x over 3 equals to total counters in A. Okay. The number of counters in B is half the number of counters in A. So total B is going to be 8x over 3 divided by 2, which is 8x over 3 times 1 over 2, and that is 4x over 3. So they're asking us to show the total number of counters in A and B is 4x. So if we add 8x over 3 and 4x over 3, that is 12x over 3. And if we simplify 12x over 3, that equals to 4x, which is exactly what they're asking us to prove. So that's your answer. Question 11 says, Mira records the speeds in miles per hour of some cars on a road on Friday. She uses her results to work out information in this table. So what we have is the lowest speed, the lower quartile, median, interquartile, range, and the range. So for the box plot, we need the upper quartile, which is basically going to be the interquartile being added to the lower quartile, which is 47. The reason why we're adding them is because interquartile range is your upper quartile minus lower quartile. So when you make upper quartile the subject, it's basically interquartile plus the lower quartile. Then we need the maximum speed as well. So range is your max minus min. So we have the minimum speed. So maximum would be range plus minimum. So max speed is going to be 37 plus 25, which is equal to 62. So now that we have this information, we can just plot this. Lowest speed is at 25. So 1, 2, 3, 1, 2, 3, 4. This is 25. Maximum speed is 62. So this is where we draw our whiskers. Then for the lower quartile, that's 35. So 1, 2, 3, 4, 5. Upper quartile is 47. 1, 2, 3, 4, 5, 6, 7. So this is our box plot. And for median, that's at 40. So this is it. This is our box plot. Then Minna also records the speed of some cars on the same road on Sunday. She uses the results to draw this box plot. Compare the distribution of the speeds on Friday with the distribution of the speeds on Sunday. So if we compare the median values, we can see that for the previous one, it was 40, and over here it's 42. So clearly on Sunday, the median value is higher. On Sunday, the median value is higher, which shows that the cars were like comparatively faster on Sunday. Cars were faster on Sunday. Then we can see that the interquartile range is higher on Sunday. Because for this, the interquartile range is 15. Whereas in the previous case, interquartile range was 12. So which means the values are more spread out. You could also talk about the range. The range was also higher on Sunday. So since it's a 2-mark question, you can discuss two things. You can discuss the median and the interquartile range. Question 12 says diagram shows triangle T drawn on a grid. Enlarge triangle T by scale factor of -2 with center of enlargement 0, 0. So first thing you need to notice is that the scale factor is negative, which means the shape is going to be on the opposite side of the original shape over here in the negative quadrant, and it's going to be upside down. Center of enlargement is given over here as 0, 0. So this point over here, this point is 1, 2. And since the scale factor is -2, we're going to move 1, 2, 2 units horizontally because we have 1 unit over here, and 4 units vertically. So 1, 2, 3. This is where this point is. This is 1, 2, 3. So that's going to be 6 units. 1, 2, 3, 4, 5, 6. And this one will be 3 and 2. So that's going to be 6 and 4. So this is where it's going to come, because 1, 2, 3, 4, 5, 6 units horizontally and 4 vertically. So now if you compare the shapes, your enlargement is in the opposite direction, so the negative quadrant, because of the scale factor being negative. If it was positive, it would be in the same direction, probably on the positive side. And you can even check if the shape is correct by joining the corresponding points and seeing if they're passing through the center of enlargement or not. So this point is corresponding to this one. This point is corresponding to this one. And this one is corresponding to this. As you can see, all three lines are passing through the center of enlargement, which means your enlargement is correct. If they weren't passing through the center of enlargement, then your enlargement was wrong. So this is your enlargement of triangle T. Question 13 says there are 30 students in a class. A teacher is going to choose at random 2 of the students. Work out the number of different pairs of students that the teacher can choose. So for this, we have to choose 2 students from 30. So 30 C2, and that gives us 435. So a total of 435 combinations exist for choosing 2 students from 30 students. Next question says at the start of 2022, Kim invested some money in savings account. The account paid 3.5% compound interest each year. At the end of 2022, interest was added to the account, then Kim took £750 from the account. At the end of 2023, interest was added to the account, then Kim took £1,000 from the account. There was then £2,937.14 in the account. Work out how much money Kim invested at the start of 2022. You must show all your working. So for this, first I'm going to assume that this amount that you started with in 2022 is X. Okay. So we find the compound interest in 2022. That's going to be X, which is our principal amount, times the rate of interest is 3.5. So 1 plus 3.5 over 100 to the power of 1, because we're talking about 1 year from 2022 to 2023. So that gives us 1.035x. 3.5 divided by 100 is 0.035. Add 1, so that becomes 1.035, and you times it by x. At the end of 2022, Kim took £750 from the account. So end of 2022. That's going to be 1.035x minus 750. So that means when we start 2023, this is going to be our initial amount. So compound interest in 2023 will have the initial amount as 1.035x minus 750 times again 1 plus 3.5 over 100 to the power of 1, because we're still taking in account 1 year, not more than that. So this will give us 1.071112x minus 776.25. So now at the end of 2023, she's taking 1,000 from the account, which means we'll subtract 1,000 from this amount. So end of 2023, we have 1.0712x minus 776.25 minus 1,000, which leaves us with 1.0712x minus 1,776.25. This is the amount that she has at the end of 2023. So they say that there was then 2,937.14 in the account. So this amount at the end of 2023 equals to this. So if you put these two equal, we get an equation where the only unknown is x. So we can find the value of x using this minus 1776.25. So we add the two. Equals to 1.0712x. So that is going to give us 4713.39 equals to this. And then we divide both of them. And that is going to give us 4,400 pounds as the initial amount when we started investing in 2022. In case in the exam you come across a similar question and you're confused about your value, what you can do is you can use your answer that you get, like for x, you can reverse the question, start using that value and do everything on that value that's given in the question. You find the compound interest for each year, subtract the value, then use that new value and find the compound interest again, and then subtract the value. And after doing all of that, if you reach to the value that is given, that should be at the end of 2023, then your answer is incorrect. But if your value doesn't match, then you probably made a mistake and need to redo the entire thing. So this is a trick that you can use to easily check your answer for these type of questions. Just reverse the question, use your answer, and do everything again. And if it works, you're good to go. Question 15 says simplify fully a minus 3 whole square over 5 times a minus 3. So if we split the a minus 3 whole square, that's basically a minus 3 times a minus 3 over 5 times a minus 3. We can cancel out the a minus 3 because now the a minus 3 are shown as being multiplied. So when things are being multiplied, you can cancel them out. But when they're being added or subtracted, you cannot cancel them out. So your answer would be a minus 3 over 5. Part B says factorize 3k squared plus 11k minus 4. You can use the quadratic formula if you're comfortable with that, or you can use the splitting the middle term. So what we do is you multiply the coefficient of k squared with the constant. So 3 times 4, that gives us 12. Now we find factors of 12. Factors of 12 other than 3 and 4 are 6 and 2 and 12 and 1. Once you've listed your factors, you choose that set of factors which can be added or subtracted to give the middle term, which is 11 over here. So we know 12 minus 1 is 11. So what we do is the equation becomes 3k squared plus 12k minus k minus 4. As you can see, we just rewrote 11k as 12k minus k. If we combine it again, it goes back to the original equation. So since we can't factorize the original equation as it is, so we need to split the middle term into another number, which is the same as 11k if we combine it back, but can be used to factorize the equation. So now that we replaced 11k with 12k minus k, we factor by grouping. We divide the equation into two groups. This is one group, this is the other group. So now in the first group, we can see that we have 3k common. So k plus 4 comes in the bracket. And in the second group, we can say that we have negative 1 common. So k plus 4 again comes in the bracket. Now between 3k and negative 1, we can clearly see that k plus 4 is common. So you take that common, and in the next bracket, you write 3k minus 1. So this is your fully factorized answer for this quadratic equation. Part C says simplify fully. So we have two algebraic fractions being divided. First, I'm going to factorize 4 minus x squared. As you can see, we have two square numbers being subtracted, which means we can easily apply difference of perfect squares. Which is basically a square minus b square equals to a minus b times a plus b. Over here we have 2 squared minus x squared, which is the same as 2 minus x times 2 plus x. So replace the numerator with that, 2 minus x times 2 plus x. In the denominator, between x squared and 3x, we have x common. So x plus 3 times x divided by x plus 2 over x plus 3. Now, if you remember, when we're dividing fractions, in order for us to divide fractions, we take the reciprocal of the second fraction and change the division into multiplication. So this is exactly what we're going to do over here. I'm going to flip the second fraction and change the division into multiplication. So now it's x plus 3 over x plus 2. As you can see, 2 plus x and x plus 2 are exactly the same. Because like we're adding them, the signs are exactly the same. So we can just cancel them out. X plus 3 gets cancelled out as well because x was being multiplied to x plus 3. And like I said before, when we're multiplying things, we can cancel them out, like in a fraction. But if we're adding or subtracting them, you can't cancel them out. So now we're left with 2 minus x over x. That is your fully factorized or simplified answer. Question 16 says the functions f and g are given by f of x equals to 12 over x plus 1 and g of x is 5 minus 3x. Find f of negative 3. So simply you just substitute negative 3 in place of x and just solve the function. So f of negative 3 equals to 12 over negative 3 plus 1. That's 12 over negative 2, which gives us negative 6. Simple as that. Then it says find f of g of 1. So now we have a composite function. By composite function, what I mean is that we're using two different functions, combining them to make another function. So first, what you can do is you can begin with finding the value of g of 1. So g of 1 is going to be 5 minus 3 times 1, which is 5 minus 3, and that's 2. Since it's f of g of 1, which means f of g of 1 is the same as f of 2. Because g of 1 has the value of 2, so 2 becomes the domain of f now. So f of 2 is going to be 12 over 2 plus 1, just 12 over 3, and that's 4. Now, an alternative method is that you find the function of f of gx. So for f of gx, what we're doing is that we're basically changing the domain of x to gx, which means this function is the domain now. And by that, what I mean is that I'm going to replace x in f of x with the entire function g of x. So we rewrite that as 12 over 5 minus 3x plus 1. As you can see, 5 minus 3x took the place of x because 5 minus 6 is a new domain for f of x based on this composite function. So simplify the denominator. So that's 12 over 6 minus 3x. Now we can substitute the value of 1. So 12 over 6 minus 3 times 1. 12 over 3, and that is 4 as well. Both methods are correct. You can either find the value first and then substitute making the new domain, or you can find the function first and then find the value. Either way, it's going to give you the right answer. Then it says find the inverse of g of x with the domain of 4. So g of x has the equation of 5 minus 3x. So when you're finding inverse, what we do is we replace g of x with y first. So now what we have is y equals to 5 minus 3x. Right now, the subject of the equation is y. We need to make x the subject. So I'm going to begin with swapping y with 3x. So 3x equals to 5 minus 5. I'm going to divide 5 minus 5 by 3 because you want to make x the subject, not 3x. So last step is going to be replace x with the inverse, g inverse of x, and replace y with x. This is your inverse function. As you can see, the original function and the inverse function are exactly the opposite of each other. Whatever operation, like the term is forming in the original function, in the inverse is doing the opposite thing. So that's your answer. Question 17 says a ball is thrown upwards and reaches a maximum height. The ball then falls and bounces repeatedly. After the nth bounce, the ball reaches a height of hn. After the next bounce, the ball reaches a height given by hn plus 1 equals to 0.55 times hn. After the first bounce, the ball reaches a height of 8 meters. What height does the ball reach after the fourth bounce? So basically, h1 is 8. So if h1 is 8, when n equals to 1, so over here it's going to be h2 equals to 0.55 times h1, which is 0.55 times 8, and that is going to give us 4.4 meters. Now we can use this to find h3, which is going to be 0.55 times h2. So 0.55 times 4.4, that is going to give us 2.42 meters. So similarly for h4, which is what they're asking us to find, the height after the fourth bounce, we multiply 0.55 with h3, and 0.55 times 2.42 will give us the value of 1.331 meters. That is your height for the ball after the fourth bounce. Question 18 says, ABCD is a quadrilateral. The area of triangle ABC is 54 centimeters squared. Calculate the area of triangle ACD, giving your answer correct to 3 significant figures. So we have been told that the area of this triangle is 54 centimeters squared. So when you have a triangle, which is non-right angle triangle, the formula for the area is 1 over 2 AB sine of angle C. Basically, this formula is applicable when you have a triangle, and in that triangle, you have two lengths and the angle between them. Over here, you can see that we have one length and an angle, but we don't have the third length. We don't have the second length, which is AC. But what we can do is we can find AC using the area, because 54 would equal to half of 17 times AC times sine of 35. So 54 times 2 divided by sine 35 times 17. And that will give us the value of AC, which equals to 11.076 centimeters. That is AC. So 11.076. If you look at the next triangle, A, D, C. In this triangle, we can see that We have two angles, we have a length. We can easily find the third angle by subtracting 57 and 48 from 180, which is going to give us the value of 75. So we have the third angle now. If we have three angles and we have a length, we can easily use sine rule. Why? Because for sine rule, what we need is a complete set of angle and length to find other unknown values. A complete set of angle and length is basically your angle D and the corresponding length. So sine rule, over here we have angle 57 and the length 11.076. They want us to find the area of triangle ACD. So if we have this length, we can either find this length or this length. Both ways we can find the area of the triangle because we need two lengths and the angle between them. I'm going to use the length of DC in this case. You can use area as well. It's up to you. Both ways you'll get the right answer. So for DC, my sine rule equation is going to be 11.076 divided by sine of 57 equals to DC over sine of 75. As you can see, I use the angle opposite to the length. That is the complete set of angle and length for sine rule. So 11.076 times sine of 75 divided by sine of 57 equals to DC. Plug this in your calculator, and what you should get is 12.76 for DC. So now that we have this, we can easily use the area formula because we have two lengths in the angle between them. So area of ACD is 1 over 2 times 12.76 times 11.076 times sine of 48. And that will give us the value of 52.5 centimeters square, correct with three significant figures. Question 19 says R equals to P over Q. P is 5.88 times 10 to the power of 8, correct to three significant figures. Q is 3.6 times 10 to the power of 5, correct to two significant figures. Work out the lower bound for R, giving your answer as an ordinary number correct to the nearest integer. You must show all your working. So first thing, when we're talking about upper bounds and lower bounds in division, you need to remember that if we're trying to find the lower bound, that means your numerator will be lower bound and denominator will be upper bound because we need the least possible value. If it was the upper bound of R, then the numerator would be upper bound and denominator would be lower bound because we're dividing a bigger value by a smaller value, and that would give us the maximum value. So for lower bound of R, we divide lower bound of P by the upper bound of Q. In multiplication, let's say you multiply the lower bound with the lower bound and the upper bound with the upper bound to find the upper and lower bounds. But with division and subtraction, the rule is slightly different. So now that we figured out what we need for P and Q, next what we need to do is we need to find the degree of accuracy and then how we would find the lower bounds and upper bounds. So if we talk about P, in this question, they are saying that correct two significant figures. So when we have significant figures, we use the significant figures to find the degree of accuracy. So since it's three significant figures, if I write 5.88 times to the, if I write 5.88 times 10 to the power of 8, if I write 5.88 times 10 to the power of 8 as an ordinary number, that's going to look like this. And for Q, 3.6 times 10 to the power of 5, that's going to be this. So since for P, it says three significant figures, so third significant figure comes over here. This is the third significant figure over here. And for Q, your second significant figure is this. In whole numbers, your leading zeros are not considered to be significant figures. So 5, 8, and 8, these are significant figures. And 3 and 6 are significant figures in Q. Third significant figure in P is 8. So which means the place value of this is 1 million. This is the million place value. And for Q, our place value for this second significant figure is 10,000. So in significant figures, you use the place value of the significant figure nearest to that they've highlighted and then divide that place value by 2. So for P, it's going to be a million divided by 2, which gives us 500,000. So we will subtract this from P to get the lower bound. So lower bound of P would be 588,000,000 minus 500,000. This will give us the lower bound, which is going to be equal to 587,500,000. Similarly, for Q, we're dividing 10,000 by 2. That's going to give us 5,000. So for the upper bound, I'm going to add 5,000 to Q. So 360,000 plus 5,000, that is 365,000. This is your upper bound of Q. So now for the lower bound of R, we divide this by this. Write that again. 500,000. So this will give us the value of 1610.96, which can be rounded to 1611. This is the answer as an ordinary number correct to the nearest integer. So once again, when you have significant figures, first write your number, the number given if it's written as a standard form, write it as an ordinary number, figure out what this place value is of the significant figures they're talking about. So if it's correct to the nearest 3 significant figures, then you look at the third significant figure in the number, figure out the place value of that number, then you divide the place value of that number by 2, and then you add or subtract that from the given number to find the upper and lower bound. So in this case, the answer is 1,611. Question 2 says x minus 4, x plus 2, and 3x plus 1 are 3 consecutive terms of an arithmetic sequence. Find the value of x. So when we have an arithmetic sequence, that means there's a common difference between each term. So the difference between x plus 2 and x minus 4 is basically the same as the difference between 3x plus 1 and x plus 2. So that's x plus 2 minus x plus 4, which is 6. We have 3x plus 1 minus x minus 2, which is 2x minus 1. So since the difference is common, so that means 6 equals to 2x minus 1. 6 plus 1 over 2 equals to x, which is 3.5. That is your answer. Then in part B, it says y minus 4 y plus 2 and 3y plus 1 are three consecutive terms of a geometric sequence now. Find the possible values of y. So when we have a geometric sequence, we have a common ratio. So common ratio is going to be the division of two consecutive terms. So y plus 2 divided by y minus 4 is the same as 3y plus 1 divided by y plus 2. Two consecutive terms being divided, the bigger one being on the top, will give us the same ratio as that between any other two consecutive terms in the sequence. So that means these two are equal to each other. Cross multiply. We have y plus 2 squared equals to 3y plus 1 times y minus 4. Y plus 2 squared is y squared plus 4y plus 4. And this is 3y squared minus 12y plus y minus 4. So y squared plus 4y plus 4 equals to 3y squared minus 11y minus 4. Collect all the terms on one side. So 3y squared minus y squared minus 11y minus 4y minus 4 minus 4. That's 2y squared minus 15y minus 8. So now we factorize this quadratic equation. So 2y squared minus 15y minus 8. If you multiply 2 and 8, that's 16. Factors of 16 are 2 and 8, 4 and 4, 16 and 1. Since our middle term is 15, we know 16 minus 1 is 15. So we can replace 15 with negative 16y plus y minus 8. Between the first two terms, we have 2y common. So y minus 8. And between the last two terms, we have 1 common. So again, y minus 8 inside the brackets. Between 2y and plus 1, we have y minus 8 common. So y minus 8 times 2y plus 1. One value y is 8 and the other value is negative 1 over 2. These are your possible values of y. Question number 21. The diagram shows a circle radius r centimeters and two regular hexagons. Each side of the large hexagon ABCDEF is a tangent to the circle, and each side of the smaller hexagon PQRSTU is a chord of the circle. By considering perimeters, show that pi is less than 2 root 3 but greater than 3. Okay, so this is a slightly tricky one, but if you just break it down, honestly, it's not that difficult because at the end of the day, they've given the answer in the question. So if you just like manipulate the question, you can reach the solution. So let's begin with understanding the formulas that we'll use. We know that for the hexagon, it's a regular hexagon, so which means all lengths are equal. So if this is A, this is also A, this is also A, this is also A, this is also A. So perimeter of the hexagon is going to be 6 times A. Same for the outer hexagon, the perimeter is going to be 6 times whatever the length is. For the circle, the circumference of a circle is 2 pi r. They have said that the radius is r centimeters. So if we draw the radius, these two lines represent the radius because we're coming from the center. This is r and this is r, and we're going towards the circumference. Now, if it's a regular hexagon, if we divide the hexagon into 6 equal triangles, we can clearly see that all of these are going to be 60 because 360 which is the angle of a complete circle, divided by 6 is 60. So these are 60. This is R, all of these are R as well. Now, if we find these two angles, we know that the radius is the same for each length. So it's an isosceles triangle. So for angle P, if we do 180 minus 60 divided by 2, that also gives us 60, which means that these are all equilateral triangles inside the hexagon. So using this, we can say that this length is also going to be R. Because if the angles are equal, they're all 60. It's an equilateral triangle, so the lengths are also going to be equal. So for your hexagon, the small hexagon, perimeter for the small hexagon, the perimeter of PQRSTU is going to be 6 times R, because the length is R for this hexagon. Okay, so right now we have the formula for the circumference. We have the perimeter for the smaller hexagon. Now for the large hexagon, I'm going to erase all of this. So if we draw a line from over here, this is our center. From the center towards the hexagon. So we know that the hexagon that is outside the larger hexagon, it's a tangent to the circle. Now the angle that the radius makes with the tangent is 90. This is a 90 degree. Okay. So it's a 90 degree. If I draw a line from here to here, this is a right angle triangle. This line is going from the center towards the circumference of the circle, which means this is R. Okay. And we already said that if we divide the shape, once again, this is also regular hexagon. If I divide the shape like this into equal triangles, we can once again see that we're getting 6 triangles. 1, 2, 3, 4, 5, 6. And if we divide the angle, 360 divided by 6 is 60. So if this entire angle is 60, this is 30. So if I highlight this right angle triangle over here, that I'm trying to focus on this, we can see that this would be 60. So if we draw this separately over here, it's a special right angle triangle. 90, 30, 60. So this length is given as R. We know that. So in a 30 to 60 to 90 ratio, we know that this is going to be double of R. We don't know what this is, but since the 60 length is given as R, so that means 30 length is going to be R over root 3. Because in a special right angle triangle, the ratio of lengths are for this x to x root 3 is to 2x. But since there is no root 3 with the 60 length, so that means the 30 length is getting divided by root 3. Okay. And for 90, that's going to be twice of that. So that's going to be 2r over root 3. So which means this length over here, that is r over root 3, half of AB basically. So if half of AB is r over root 3, that means this is going to be r over root 3 as well. So the entire length AB r over root 3 times 2, that's 2r over root 3. So to find the perimeter of A, B, C, D, E, F, we times 6 by 2r root 3, which is 12r root 3. So we have an expression for all three. For the circumference, it's 2 pi r. For the smaller hexagon, it's 6r. And for the bigger hexagon, it's 12r over root 3. So now I'm going to use these to create this inequality and then solve to get the final answer as given in the question. So the bigger hexagon, 12r over root 3. In the middle, we have the circumference, 2 pi r, and the smaller one, which is 6r. So to turn this into this, we have to rationalize the third. So to rationalize the third, we're going to multiply and divide it by root 3. So 6r, 2 pi r, and this is going to be 12 root 3r divided by 3. 3 ones are 3, this is 4. So 6r, 2 pi r, and that is 4 root 3r. We can see r is found between all three, so the r gets cancelled out. Over here we have 3, over here we have just pi, so that means let's divide all 3 by 2r because this is what's not present over here. So 2r divided by, so 6r divided by 2r is 3. 2 pi r divided by r, 2r is pi. 4 root 3r divided by 2r is 2 root 3. And this is exactly what the question was asking us to prove. I know it looks very confusing, like if you just, for the kids who saw this like the first time in the exam, but like you just need to break it down. You need to find expressions for all three separately. For the smaller hexagon, it's very simple, like you saw, like it was the same length because it was an equilateral triangle between each. So we found r as the length for the smaller hexagon. For the circumference, very simple because they've given the radius as r, so you just put it in the formula. For the bigger hexagon, it was slightly difficult, but you could have still used the same. You could even use the equilateral one over here as well. Like made AB the equilateral and use that. I just split it all like in another triangle already and then used it. But you can even use the equilateral formula on the bigger hexagon. Find your expression, find your length for AB using the special right angle triangles, and then put them in an inequality and simplify to get the same thing.